Section, we are going to look at how to look at the polynomials, linear factors, and zeros, and then graph them. So our objective for today is that I will be able to use the zeros. Zeros, remember, is what makes the function zero, and end behavior of the function to sketch a graph. So let's take a look at the first question. Find the zeros of the function, multiplicity of each zero, then state its degrees, and in behavior, finally sketch the graph. So if we look at this and say the first thing is to find a zero. Zeros means what makes y zero. So we set the function equal to zero, and essentially we are finding the x-intercepts. And again, if the function is in factor form, like so, then you can set each factor equal to zero. So this one, x plus 2 equals 0, x minus 1 equals to 0, x minus 3 equals to 0, and then you solve each one. So x is negative 2, x is 1, x is 3. And the different thing about this one is that you can see that there is a square here. So square, remember, means that there are two of the same thing. Two of what? Two of x plus 2. So essentially, we can actually write this as x plus 2, correct? So then if we were to set each one equal to 0, we would have 2x equals minus 2, which means there are two of them, and that's what we're talking about multiplicity. Multiplicity, the key word here, is that when there are more than one of the same zero. So let's go ahead and list them now. So we have three zeros, x equals negative 2, x equals 1, and x equals 3. And in these three zeros, we have 2 of negative 2. And when we have 2 of negative 2, we say m, which is multiplicity, is 2. And x equals 1, there's only one of them, so m equals 1, and this one is m equals 1 as well. So how many degrees does this have? Well, you can see that there are 4 zeros, so that means the degree is 4. What if you didn't see that? Well, you can always look at the function, like so. So you can see that x plus 2, you can see this is linear. And when there's a square, that means there are two linear ones, so that means that's 2 degrees already. There's another one here, so that's 3 degrees, and another one 4 degrees. So there's a total of 4 degrees. And why do we do that instead of look at each one? Because this is not in the standard form of a polynomial. This is in the factored form of a polynomial. Therefore, we cannot look at the quote-unquote highest exponent. We only look at the highest exponent when it's a polynomial standard form, meaning everything is multiplied together. In this case, we have to kind of count the degrees. So there's a total of 4 degrees. If it's 4 degrees, then we can predict the end behavior. From the previous section, we know this is going to be up, up. All right, let's go ahead and graph this. So we know that there are 4 real zeros. One is at negative 2, 1, and 3. These are the only 3 places this graph crosses the x-axis or touches the x-axis, right? That's when y is equal to 0. We know the end behavior is going to be up, up. So then at the last 2 zeros, which we're talking about this one and this one, the graph is going to go up, up like so. So then the only last thing you have to ask yourself is, how is it going to connect the middle? Well, that depends on the multiplicity. If it is an odd multiplicity, like 1 or 3 or 5, so like there's 1 of them, there's 3 of them, or there are 5 of them, then they are going to cross the x-axis. If you have an even multiplicity, that is, you have 2 of them, you have 4 of them, or you have 6 of them, so some even number of the same kind, then you're going to bounce off x-axis. Okay, what does that mean? Let's take a look at this one. First, at negative 2, there are 2 of them. 2 means it's an even number. So if there's an even number of them, it's going to bounce off the x-axis. What does bounce off mean? So you can see that this graph here is coming down here, touches -2. It says if it's going to, at -2, it's going to bounce off. Bounce off means it's going to go up like that. So like think of the x-axis as a wall. So this graph comes down here, bounce off. So the graph's going to go like that. Next, it tells us it has to cross at 1. At 1, there's only one of them. One of them means that's an odd number of them. Odd number means it crosses the x-axis. So at 1, the graph is going to come back down, and when it hits 1, it's going to cross, right? This is the x-axis, so it's going to cross, go through x-axis. How high does it go? Well, there are a few things we can do to kind of figure out approximately. So first, we know that if x is equal to 0, that's where we have the y-axis. So you can put in 0 here and then try to calculate. So if you put in 0 here, you get 2. 2 squared is 4 times the -1 here is -4 times the -3 here is 12. So it's going to cross the x-axis at 12. So we can see that this is going to go up to 12, come back down to 1, and at 1 it's going to cross because that's what the multiplicity tells us. And then the last thing is at 3. At 3, odd multiplicity, it's going to cross again. So then it comes back down somewhere here and then up. Now, if you ask me, do we have to draw a very, very accurate graph? No, we're just going to sketch the graph, which means just kind of get the basic behaviors correct, and we're good. If you want a really accurate graph, we have to find every single point in order for that to happen, and we're not going to do that in this chapter. We're just going to look at kind of roughly how it looks like by the zeros and by the multiplicity. All right, now let's have you practice this. So remember, you're going to look at the zeros, the multiplicity of each zeros, find the degrees so that you can find the end behavior, and then you're just going to sketch a graph. So go ahead and give that a try. Pause the video, come back and check your answer. All right, go ahead and check your graph. Did you get a correct graph? This one has an end behavior of down, down because there's a negative in the front, which means there's a reflection over x-axis. All right, let's go ahead and try another one. This one is not in factored form, so that means you have to factor first. So go ahead and give this a try. So I have factored the polynomial and found the zeros. And so far, I can see that there are three degrees, which the polynomial already told me there are 3 degrees. And we can see that there are 3 zeros. So we can predict the end behavior to be down up because there is also no negative number or leading coefficient. So this is going to be a normal 3 degrees. So then we put 3 zeros on here, -3, 0, and 5. We know it's going to go down, up. There's odd number of each one, so that means every one of them is going to cross, like so. All right, now we're going to go backwards. So if the question says, what is the polynomial function in standard form? So remember, standard form means we're going to multiply all the factors together to start from highest degree to lowest degrees. It says that we have a few zeros, for example, -2 and 2. Then what would be the polynomial function? All right, let's start with -2 and 2. So let's say the 0 is x equals -2. So now you kind of think backwards. If x is equal to -2, then what would have been the factor so that when I set it equal to 0, I would get a -2? Well, it's pretty easy. You can just kind of go backwards and add 2. So x plus 2 is 0. So that means, if I were to solve for a factor from a factor, I would have to do that. So that means x plus 2 is a factor. So let's just kind of review. This is what we call a 0. And then when this is set to 0, we call this a factor. So kind of know the difference. All right, so same thing. If the second one, if x is equal to 2, then what was the factor? Again, you just subtract that number. So x minus 2 equals 0, which means x minus 2 was the factor. So then this polynomial function that has the two zeros, -2 and 2, had these factors, x plus 2 and x minus 2. So you see how I put the factors in parentheses? That's how you write it out in a factored form. And make sure we have a y equals because we're talking about a function. So now the question wants us to write the polynomial, which we did, but in standard form. In standard form, we got to FOIL this whole thing out. So FOIL this, we get x squared minus 2, x plus 2, x minus 4. You can see that cancels out. So x squared minus 4 is the correct polynomial function. Okay, let's try another one. What is the polynomial function in standard form with the zeros x equals -2, multiplicity of 2, and then x equals 3 and 0? All right, let's go ahead and write that out. So we know that, every time they give us a 0, we're going to subtract it in order to find the factors. So that's pretty easy. So if x is equal to 2, then the factor must have been x minus 2. It tells me here that m equals 2, which means there are 2 of them. So then I can just say, yeah, there is a square. There are 2 of them. One of them is 3, so that means x minus 3. One of them is a 0. Okay, so you kind of go backwards and say, what would have been the factor if the 0 was 0? That would mean it was just an x. Okay, so let's go ahead and multiply everything out. X minus 2 squared, we are not going to distribute the exponents. We are going to FOIL. Now, if you want to do this really quickly, you have to think of some shortcut. So x minus 2 squared, I'm going to do this on the side, but you really shouldn't do this on the side. You're just going to, once I show you, you have to do this in your mind in the future. So if you were to FOIL, then you would have to do this. You would get x squared minus 2x minus 2x plus 4. And then you get x squared minus 4x plus 4. Now, you're not going to do that every time. You're just going to use shortcut. So you can see that there's a pattern here, right? X squared. So if you had just this part, then you can see that this first x squared comes from squaring this one. This minus 4x, you can see that it came from minus 2x and minus 2x. How do we get those? Well, that's just following the first and the last and then the 2 in the middle. So essentially, it's always going to be these two terms multiplied together and doubled. So you can actually just do that. So x times -2 is minus 2x. Double that is minus 4x. How will we get that last number? That last number is always the last number multiplied by itself. So it's going to be -2 squared. That's how we get this plus 4. So if we were to practice with something else, let's say x minus 3 squared. So then we can just say square the first one, multiply the two terms together, which is minus 3x, double that, which is minus 6x, and then square the last one, plus 9. Okay, let's try another one. So if we had x minus 4 squared, we would square the first one, multiply the two numbers in the middle together, which is minus 4x, double that, which is minus 8x, and then square the last one, plus 16. So not hard, just make sure you kind of remember the middle one is doubled. Okay, so this one is x squared minus 4x plus 4. And then if you multiply the the two polynomial factors together, you get x squared minus 3x. Now, FOIL. All right, we have no other way but to just really FOIL this. So the first times the first, which is x to the fourth, and then this one times the last, we get minus 3x cubed. This one, we get minus 4x cubed. This one, we get plus 12x squared. This one, we get 4x squared. And then last, we get minus 12x. All right, combine like terms. X to the fourth minus 7x cubed plus 16x squared minus 12x. And that is the answer. All right, go ahead and give the last one a try. Pause the video, come back and check your answer. All right, go ahead and check your answer. Make sure that it's correct. And that's it for today.